Hello everyone, welcome back to my channel. Let us now discuss Biot-Savart Law, one of the phenomena in the electromagnetic field. We know that when a current is flowing in a conductor, a magnetic field is produced surrounding to it. Right? So here we have considered one current carrying conductor. Let's say current I is passing through this conductor. We have considered one small element of this conductor of length say dl, and dl bar is the line element vector which is tangential to this. The current passing through this line element will be called as the current element. Now we want to find out, due to this current element, what is the magnetic field at a point P at a distance r from this current element. Here we have taken the position vector r bar joining the current element to the point P, and the angle between the current element vector and the position vector, let's say theta. Now according to Biot-Savart law, the magnetic field produced at the point P, if it is say dB bar, then the magnetic field dB, the magnitude of the magnetic field produced dB, is proportional to current I in the conductor. That means if the current passing through the conductor is increased, the magnetic field produced at the point P will also increase. It is proportional to the current I. The magnetic field produced dB is also proportional to the length of the current element, which is dl. So here the length of the current element is dl. So if the length is increased, the magnetic field produced at the point P will also be more. So it is proportional to the length of the current element. The magnetic field dB is also proportional to the sine of the angle theta. So here the angle is theta. The sine theta value, if it is increased, then the magnetic field will also increase. And then it is depends on the distance between the current element and the point P. If the distance is increased, then the magnetic field produced will decrease, and it is given by proportional to 1 by r square. It's inversely proportional to the square of the distance. That means if the point P is nearer to the conductor, the magnetic field produced will be more. If the distance is increased and the point is taken away from the conductor, the magnetic field produced will be going on decreasing. Now, therefore, we can write the mathematical form of the Biot-Savart law as dB bar is equal to mu by 4 pi into I dl bar cross r cap by r square. So here it includes all the points we have discussed here. It's proportional to the current I, it's proportional to the length of the current element dl, and it is proportional to the sine theta that is included in this cross product, because we know that when you take a bar cross b bar, we get AB sine theta. So similarly here dl bar cross r bar r cap, we have taken the unit vector along the position vector, that is r cap, and it is inversely proportional to the square of the distance, so that is also there. So this equation gives us both the magnitude as well as the direction of the magnetic field produced by the current element. Now the direction, if we look at it, the direction of dB bar is perpendicular to the plane containing the current element vector and the position vector. So here therefore it is perpendicular to the plane containing dl bar and r bar. That means it is here proportional, it's perpendicular to the plane containing dl bar and r bar, which is perpendicular to the plane of this paper. So that is the direction of the magnetic field produced due to the current passing through this conductor.